Hi, welcome everybody. How are you doing? Thank you for all coming to the room. That's always nice to socialize afterwards and have some drinks and I don't see any snacks, so I'll have to fix that. Okay. So I'd like to introduce, it gives me a great pleasure to introduce Libby Sharman, who was an undergraduate student just like you guys here at Wits, and she did her undergrad and honors here. And then she did her master's with Judith Kinnaird. And then she went on overseas to McGill in Canada for her PhD. And then she continued on traveling and working for a number of companies and all over the world. And she's now an exploration geologist for BHP in Toronto as a superintendent Geology Canada for metals exploration. And so she's got contributes to the global exploration strategy through project generation and prospectivity analysis on a global to regional scale, which is another way of saying she's gotten very high up in BHP. So we're very proud of her, and I was very excited. I'm friends with her on Facebook. So this is another example of a social media connection where I just reached out to her and she said she'd be delighted to give a talk here. So we're super happy to have her. And with that, Libby, I'll send it over to you and you can correct any of the introduction I got wrong.
Thank you so much, Sue. Hopefully you can all hear me all right and see my screen. It's an incredible honor to be presenting this today. And I was thrilled when Sue reached out and asked me to participate. I'm going to be talking to you today a little bit about mineral systems, which is a key component that we use within BHP for mineral exploration and other things, and how the use of mineral systems and application of mineral systems in metals exploration is going to shape what our geoscientists of the future look like and how we can prepare for that. Hang on. I'd like to start with a land acknowledgement. While I'm here in the UK at the moment, I do live and work in Toronto in Canada, which is on the traditional territory of many nations. For thousands of years, it's been the traditional land of the Mississaugas of the Credit, the Anishinaabe, the Chippewa, the Haudenosaunee, and the Wendat peoples, and it is now home to many diverse First Nations, Inuit, and Métis people, and it's important to acknowledge that traditional land. I would also like to acknowledge that this talk is a collaboration between myself and many of my colleagues, in particular Nicole Januszczak, who is our practice lead mineral systems, and her and I work very closely together in driving the application of mineral systems within metals exploration. What I'm going to do today, Sue sort of asked me to focus a little bit on my career, how I got to where I am. So I'm going to touch on that briefly and then sort of explain how that feeds into where I think exploration's going, the importance of mineral systems, and then how that impacts us as geoscientists. So to start off with, and as Sue mentioned, I have an academic foundation. I did my undergrad, honors, and master's degrees at Wits University. My master's degree was with Judith Kinnaird on the Platte Reef. I was the first person to apply multiple sulfur isotopes to an ore-forming system and identified various inputs into the Platte Reef using that sulfur isotope work. I then moved to McGill, which is in Montreal in Canada, for my PhD, and I carried on the multiple sulfur isotope work, but in this case, applying it to VMS deposits within the Noranda district, which is also in Eastern Canada. I also was able to publish that paper in Mineralium Depositor, and up here we have one of the diagrams that came out of all of that work, which is a sort of ideal sulfur cycle within a VMS system within the Archean, and all of the various inputs and multiple sulfur isotope values that you would expect to see. I've been lucky enough to present at a variety of different conferences globally, both talks and posters. And if there's one thing if you're looking to take away things of my career and how I got to where I am, it's definitely a case of saying yes to opportunities when they came up and being prepared for those opportunities. Paul Nex, who I think is on the call, very famously gave a Geotalk about 15 or 16 years ago, which was entitled "Never Say Never." And I think I've taken a lot of those messages away and always tried to be in a position to take advantage of an opportunity that's presented itself to me. Since leaving academia, I have continued with my research and publication work. I was very lucky to lead a perception survey which focused on Aboriginal Canadians' opinions of the mining and mineral exploration industry in Canada. And that was published about 10 years ago now. And more recently, I was one of the lead editors for the updated CIM special issue on porphyry deposits of the Northwest Cordillera of North America. And again, that was a perfect example of being in the right place at the right time and someone asking me if I would lead that compilation and being in a position that I was able to. I have in my career worked in a lot of different places, starting again with the research component, where thanks to that, I am now within my company considered a subject matter expert, both for mineral systems and nickel sulfide deposit. I've been very lucky to be able to work in the project generation and leadership space for research during my time with the Mineral Deposit Research Unit at the University of British Columbia, also in Canada. And being in a position for a lot of very interesting, innovative technique development, which has really set me up for thinking about how you can do different things differently in your day-to-day career. And when I finished my PhD, I went to work for a series of junior exploration companies, which generally lead smaller scale exploration than the major companies that are particularly active in South Africa. The joy of this is you get to work with small, agile teams where you get to do everything. I have been in charge of ordering groceries for 30-man drill camps. I have been working in remote locations, which include access only by either helicopter or float plane. From the middle of winter to the heat of the summer, you get to be involved very early on in the technical management and reporting of the projects, because you may be one of only a few geoscientists on the team. And the teams tend to be very diverse. They come from a lot of different backgrounds and a lot of different experiences. And you really band together to achieve amazing things. As I mentioned, I've also spent time in the communications field. This was in the downturn of 2012, 2013, where geoscientist jobs in Canada were particularly difficult to come by. And I took the opportunity to shift over to a community engagement communications company. Through that role, I put together technical reports for very broad audiences. I did community-based Indigenous engagement work, where you're going into communities to discuss different projects and how things can be done in a respectful way with the permissions of the communities. Crisis communication preparedness, notably when the Mount Polly tailings dam failed in Western Canada. I was in charge of the team that led the crisis communications in response to that, and to make sure that the right messages went out that were science-based and portrayed the accurate information of what was happening. And then on a fun side, I got to do event management. So quite a few receptions, parties, short courses, things like that, which are amazing social events and give a fantastic opportunity for improving your network. And then lastly, but no means least, I've been with BHP for 5 years now. It is one of the world's major mining companies. We have mines globally, including iron ore, copper, nickel, coal, across the board. And as Sue mentioned, my role has been a global generative focused role until recently, when I moved up to Canada to take over setting up the new Canadian exploration team. Dominantly a mineral systems approach to everything. And the ability to demonstrate team leadership across diverse disciplines. So interacting with groups, not just within metals exploration, which is actually a relatively small team within BHP, but also within our operations and other groups. Part of the joy of this was a really fun slide to put together because I've never really visually looked at where I've been lucky enough to travel through my work. Just a bit of an indication, the green countries here are countries I've lived in. And then the yellow countries are countries that I've had the opportunity to work either on site in or on compilation projects and data analysis projects. Obviously, again, starting off in South Africa with nickel sulfide and PGE focused work. Moving across to Canada, where I've touched on quite a lot of different commodities, including sedimentary copper in the Arctic, porphyry copper in Western Canada, and nickel sulfide VMS and gold mineralization in Eastern Canada. And then a lot of different porphyry copper, sed copper, and nickel sulfide assessments globally, including within Zambia and the DRC, Morocco, porphyry copper in the Balkans, nickel sulfide and porphyry copper in Fennoscandia, and all of these things. And these just, there's a few photos down the bottom here that I thought really captured the diversity of career that I've been very privileged to have, which take me from the mountains of British Columbia through to volcanoes in Ecuador. Of course, a core shack in northern Quebec. You can never quite escape the core shacks. Our office building in Houston, working with our petroleum team. And then this picture was actually taken a couple of months ago in the field in northern Canada. And so this is just a little bit of an overview of how I've got to where I am. And I think hopefully this then leads into discussing where we're going as a community as a whole, and how we can continue. You know, this is the past, this is where I'm at now. And what I'm hoping to talk to you today is the future, and how as geoscientists, we're going to be developing forwards. So what is changing in exploration? You know, just a bit of a thought of where we're at right now. And I don't think it's a surprise to anybody that technology is changing the way we do field work. This used to be the case. This is again a photo of me in a core shack in northern Quebec from probably about 12 years ago now. But I'm logging core on a laptop. And when I started logging core on the Bushveld, it was with a tiny little tablet with running an Excel program. And so technology is changing the way we do things. And from this computer-entered core logging, we now have automated drill core logging, where you put the core through a scanner, it takes high resolution images. It also does a series of other sort of XRF and shortwave infrared analyses, which assist the geologists with interpreting the core. We have had a massive increase in remote sensing. In places, and this is an image of a drone actually carrying geophysical instrumentation. And then finally, things like machine learning and artificial intelligence coming on board, which I'll talk about. Technological changes, one of the questions we have to ask ourselves is, are we as exploration geologists is it that fewer geoscientists are going to need to be required on projects and on site and being done by people in other fields? So are we the dinosaur saving the mammals? Dynamicists and these sorts of things. You'll be pleased to know my thought on this is no. Otherwise, this would be a very short talk, although giving more time perhaps for socializing and chatting afterwards. But part of the reason I think that the future is bright is to look at where we've come in the last 30 years. and some of the changes that have happened. I mentioned the changes in computing, the fact that we now have the world at our fingertips. We have global reliable GPS units that we take into the field that fit into our pocket. The use of helicopters. I've mentioned remote sensing. We have come leaps and bounds in our understanding of ore deposit models, and mineral systems is in the realms of geophysics and geochemistry. The miniaturization of geophysics has allowed it to be has very much allowed us to change the way we collect and analyze. Changes are coming next, we're in a pretty good place. The next thing that we are going to have to consider facing. This graph shows the cumulative contained nickel of all of the resources, nickel sulfide resources in the world versus time, starting with the discovery of the Sudbury here is all of the nickel resources globally as a cumulative graph. And then the sort of dark blue with the triangles is all of the mines. So that's everything that is being exploited today. And you can see that from the discovery of Sudbury pretty much through to the early 60s, that gray line of all of our known resources and the blue line of all mines pretty much tracked level with each other, which meant that we were finding deposits that were of a good enough quality to put into production. You then have a very big jump here, which was the discovery of Talnac, which pumps the line up quite a lot for everybody. But then what you can see is from the 60s onwards, the total discovered nickel versus the ones that were actually put into production, there's an increasing quality gap that's developing. And that means that while we are still finding deposits, we are struggling to find deposits that are good enough to put into production. And this is a big question for mineral exploration is what are we doing wrong? And how can we do it better? And one of the things to think about is every single one of these big jumps was done with the discovery of a new nickel camp. And so how do we find the next new search space? How do we find that next new camp to allow us to continue to find the resources that we require for our continuing growth, especially within the green economy and the importance of things like nickel and copper? At BHP, our thought is the answer to this is mineral systems. The way mineral systems work is that they take an ore model or a particular deposit type and they break it down into what are the absolute necessary processes that we have to have for that ore deposit to form. And so this isn't geological observations. This isn't about, oh, we see xenoliths of footwall rock in the Platte Reef, so we know there must have been sulfur contamination. The process is you need to have formed an immiscible sulfide liquid. There's two common examples used here. This diagram on the left is from McQuaig and Hronsky from 2014. And they break it down into four main processes. The fertility of a system. In the example of nickel, this would be the composition of the magma to allow it to carry a lot of nickel and to form the deposits that we need. The lithospheric architecture, which is the pathways that the magma is going to take from the asthenosphere up into the lithosphere. And favorable geodynamics. So what is actually the trigger that moves that magma through the system and up into areas of deposition? And then they couple that with preservation. And that is more of a mineable concept in that you need your primary area of ore deposition to get to a place where it's mineable, but not where it's been eroded away. Occhipinti et al. In 2020 also proposed a similar concept with some slight differences. They also focus on things like lithospheric architecture here, which is controlling of the movement of fluids or magmas in the system, tectonic triggers that make those things happen, common fertility elements around the compositions of magmas or fluids to move the metals that we're interested in. And then they also include things like chemical and geological gradients, which will impact locations of deposition for the ore deposit that you're interested in. And then they pop preservation down here with a more sort of graphic interpretation of where within the crust you'll be able to see these different deposit types that we're in. So how does mineral systems impact what we do on a day-to-day basis with metals exploration? And what it really does is helps us think about what the critical processes are that we're looking for and what we need to know as we go from a concept scale, which is the sort of really big prediction, regional scale part of metals exploration, when you're looking at the whole world and saying what belt or basin or district has the best potential to host the mineral system that I'm looking for. In this case, we're using the Thompson Nickel Belt, which is in Canada. And then you step through into the target phase of exploration. And this is where you step in within the mineral system of where within a specific belt or arc or basin could we have a cluster of deposits that are interesting. And then finally, once you've identified that, how you can take that one step even further in and say where within an ore body or a specific deposit have we got enough quality ore deposition to be mineable. And that's when you end up with your discovery. So you really need to be thinking about what processes are happening at what scale and how that's going to drive your exploration thought process. To take you through a quick example of this using nickel, of a couple of the things that we think about in the nickel mineral system and how we're applying them with exploration. We know with nickel sulfide deposits that lithospheric architecture or thickness is incredibly important. You have works from people like Begg et al. And Griffin et al. Who have identified that these thinning zones of the lithosphere, in particular craton margins, are incredibly important for focusing the melts that are generated by plumes up into specific areas before they move into the crust. And then you have the work of Hoggett et al. Who have sort of plotted that out visually. This is focusing in on Australia, and you can see that major ore deposit types tend to focus around these areas where the lithospheric thickness changes from relatively thick in the blue to thinner in the red. So that tells you that you want to be on a craton margin, or you want to be on a place where your lithosphere has thinned. But it doesn't tell you what's driving the clusters along certain parts of that craton margin. And so that's a really important question for your mineral system, because that's going to help you drive where you're going to target your exploration. And then you have work like from Afonso et al., who have taken multiple geophysical data sets, and they have done a series of geophysical interpretations and inversions to more thoroughly interpret the differences in the composition of the asthenosphere and how it interacts with the lithosphere in Southern Africa. And so this starts to not only help map out the major craton margins, and here's the Karpfeil craton, which you're all very familiar with, but to work out where along those craton margins you want to be based on the differences in the material of the asthenosphere. If we go from this very large scale and we step into the pore scale, we have research that's coming out of the University of Leicester, UWA, and Macquarie University that we're currently funding, where we're actually looking at the composition of various metasomatized mantle rocks and thinking and challenging the concept that your nickel mineral system has to be a dry system. convention states that most of the nickel we see in nickel deposits has come out of the melting of olivine. But